A warm welcome to everyone listening to this video lecture series. In today's lecture, I am here to discuss on the topic stability number problems using Taylor stability charts, which provide a quick and efficient method for analyzing slope stability, especially during preliminary design stages. So before moving to the topic, let's recall the slope stability concepts. In slope stability design, engineers often need quick estimates for factor of safety against failure. Detailed numerical analysis may not always be practical in early stages, and this is where a Taylor's stability number becomes very useful. So, in this lecture, we will cover the definition and significance of stability number, Taylor stability charts, solving stability number problems, and also discuss on factors affecting stability and applications in slope design. So the topic is based on the 5 stages of design thinking approach. The first stage of design thinking is empathize. So we have identified the problem statement with respect to why we are studying the stability number. The stability number provides a simple and graphical approach to evaluate the slope stability and factor of safety without complex calculations. So it helps engineers to predict the factor of safety, design earth embankments, cuttings, and understand the influence of soil parameters such as cohesion, unit weight, and slope angle. So, due to these advantages, this method is chosen in order to calculate the factor of safety and strength parameters of slope. The main objective of this topic is to understand and solve stability number problems using Taylor's charts and determine the critical height of a slope and factor of safety under given soil conditions. So the stability number depends on several factors including soil type, slope angle, friction angle, pore water pressure, unit weight and drainage conditions. Among these, pore water pressure plays a major role in reducing effective stress and slope stability. So with regards to ideate, the Taylor stability charts were developed for cohesive soils and combination of cohesive and cohesionless soils, that is C5 soils, based on extensive research. These charts provide stability numbers directly for different slope angles, making slope stability analysis fast and convenient. So there are various factors which affect the stability number. First is the type of soil, whether it is cohesive soil or cohesionless soil, and the angle of slope, and also the angle of internal friction of soil, and the pore water pressure, and drainage conditions, that is seepage condition of soil. Next is unit weight of soil and external loads and drainage conditions. So this slide summarizes how the stability number links soil shear strength, slope height and unit weight, and why it is useful as a preliminary analysis tool before applying detailed limit equilibrium methods. So this slide represents 5 stages of design thinking and how the concepts are applied in slope stability analysis for this above method. Next is curiosity challenge. For a clay slope having a cohesion 20 kilonewton per meter square, unit weight 19 kilonewton per meter cube, and angle of slope 45 degree, and height of slope is 10 meter. So from Taylor's chart, we have to calculate the critical height and find the factor of safety and comment on slope stability condition. Next is assessment. The stability number is defined as the ratio between, answer is ratio between cohesion and the product of unit weight and critical height. So second question, Taylor stability chart is used for slope stability analysis. So the references for the above topic are listed below. Thank you for listening to this video. Have a good day.